There's one last sort of problem in this section, and that's going to be constructing a polynomial given its zeros. So if we're solving a polynomial equation, we've got some polynomial equal to 0, we would start with the polynomial. Then we would factor it so that we could set each factor equal to 0, and then we would find the zeros. Here we're going to be doing exactly the reverse. We're going to be given the zeros. We know that a 0 corresponds to a factor, so then we can get to the factored form of the polynomial. And then we're going to multiply it out to get the polynomial in standard form. Okay, so my directions are up here. They say to write a polynomial with integer coefficients. Now that's telling me two things. First of all, the integers are real numbers. So even though by the time we get to part C, we're going to have some imaginary zeros, we're not going to have any imaginary numbers in our actual polynomial. Okay? And more specific than just being real numbers, they've got to actually be integers. So no fractions either. Okay. So we want to write a polynomial with integer coefficients that satisfy the following things. And we're going to write it in descending order. That essentially tells me don't leave it in factored form. Descending order means I start with the biggest power, so I've got to have it multiplied out. Okay, so part A, we're told that we want it to be degree 3, and we're given that the zeros are -2, 4, and 6. Okay, so I can say P of x, I'll call it whatever I want to. It's going to have x plus 2 as a factor, and x minus 4 as a factor, and x minus 6 as a factor. Gotta have those 3 factors. Can't have any more factors with an x in them, because with 3 factors with an x in it, it's already going to be degree 3. So no more factors with an x. Now if I wanted to have a constant factor, if I wanted to multiply this by 205 for some weird reason, I could. That would be fine. So my answers aren't going to be unique. But I can see I don't have any imaginary numbers. I don't have any fractions in here. I think if I multiply this out, I'm going to have an answer. So the simplest thing is just going to be to multiply all of this out. So I'll start with just the first 2 factors. I'm going to FOIL that. So that would be x squared minus 4x plus 2x is minus 2x, and then minus 8. And we've got to multiply that by x minus 6. Now this means I need to distribute the x to each one of these terms and the -6 to each one of these terms. I find it simplest when I'm multiplying by polynomials with 3 or more terms to do it in a vertical format, although that's certainly not necessary. This is almost like what I would do with multi-digit numbers. Okay, so I'm going to start here and say I need to distribute this -6 to each one of these terms. -6 times -8 would be positive 48. This is going to give me a positive 12x, and this is going to give me a -6x squared. Then I need to distribute the x to each of these terms. The nice thing about this vertical format is that as I do it, I can line up like terms. So x times -8 is going to give me a -8x, and I'll line that up with the 12x's that I already had. X times -2x will give me -2x squared. I'll line that up with the x squareds that I already had. X times x squared gives me x cubed. Didn't have any of those, so I started a new column there. So then I can say we've got x cubed minus 8x squared plus 4x plus 48. That is my P of x. Notice it's degree 3. I've got integer coefficients. My coefficients are 1, -8, 4, and 48. So they're all real and no fractions. Okay? And I know that I had those 3 zeros. Fabulous. Okay. So that's part A. Let's try part B. Once again, I want it to be degree 3. Looks like I've done 2 things to make life a little bit harder for us. First of all, one of my zeros is a fraction, and then I've only given us 2. So if I were to say P of x is, if 1/2 is a 0, I know that x minus 1/2 must be a factor, if negative 5 is a 0, I know that x plus 5 must be a factor. But I didn't just say these guys are zeros. I said the zeros are these two numbers, suggesting those are the only zeros. So I know in order to get to degree 3, I'm going to need to have a third factor with an x in it, but I can't introduce any additional zeros. What I'm going to have is that one of these zeros will be repeated. It's going to have a multiplicity of 2. I think my simpler factor was x plus 5, so I'm just going to introduce a second factor of x plus 5. Now, 3 factors with an x, it's going to be degree 3, but I still only have 2 zeros. It's just that the negative 5 now has multiplicity 2. All right, so I'm going to want to multiply this out, but I'm going to strategize a little bit ahead of time, because I can see I've got a fraction here, and I know I don't want any fractions in my final answer. I'm pretty sure if I just multiply this out as is, I'm going to end up with some fractions, and I'd prefer not to. But remember, we said we have to have these factors well, I have to have these two, and one of them has to be repeated, and I just chose to repeat that one. Okay. But I could have other constant factors. In particular, I could multiply by 2. Now, if I multiply by 2, and I group these two and do that first, notice when I distribute that 2, that's going to become 2x minus 1. That got rid of the fraction. So I can always do that. If I have a fraction and I take x minus that fraction, if I simply multiply by the denominator of that fraction, I will get a factor that corresponds to that same 0. If I set this equal to 0, I'm still going to get 1/2, but it doesn't have any fractions in it. That's kind of nice. Okay, so now I want to multiply this out. I'm going to just multiply those first two factors by FOILing. So that'll give me 2x squared plus 10x minus x is plus 9x minus 5. And then I still have to multiply that by x plus 5. Again, I like to use the vertical format, so I'm just going to write an x plus 5 underneath this trinomial with 3 terms here, and I'll distribute the 5. So I get negative 25, I get 45x, and I get 10x squared. Now when I distribute the x, I'm going to get negative 5x, 9x squared, 2x cubed. So we'll have 2x cubed plus 19x squared plus 40x minus 25. I'd chosen to call that p of x, although you can give it whatever name you want. That would be a solution to part B. Now again, solutions are not unique because I could have had 2 factors of x minus 1/2 instead of 2 factors of x plus 5. And once I've got something, I can multiply that by any integer because I can have additional constant factors that won't change the degree and that won't change what the zeros are. Okay. So as you're doing the homework, it's possible that you will do a problem correctly and your answer won't match what's in the back of the book because you made some slightly different choices. If that's ever the case and you're not sure whether your answer is correct, just ask. Okay. Give me a call, shoot me an email, come to office hours, say, I did question number 67 and I got this, but the book got that. Here's what I did. And do I have an alternative answer that's also correct? It's entirely possible that you do. Okay. All right, excellent. So let's try part C. Now this time I've thrown in some complex zeros. So it needs to be degree 3. My zeros are 0 and plus or minus 2i. So if 0 is a 0, x minus 0 is a factor. Now notice that's just x. Okay. So x will be a factor whenever 0 is a 0 of the polynomial. And then if 2i is a 0, x minus 2i has to be a factor. And if negative 2i is a 0, x minus negative 2i or x plus 2i is a 0. Now, you'll notice I gave you some complex numbers here. These happen to be purely imaginary, but they came in conjugate pairs because they had the opposite imaginary part. When that's the case, so I've got x times x minus 2y times x plus 2y, I'm going to choose to start with those two and multiply those out. Just because something's nice is going to happen when I FOIL that. I'm going to get x squared plus 2ix minus 2ix minus 4i squared. Now it looks like I still have some non-real stuff there, but notice the 2ix and the minus 2ix cancel, and remember that I squared is negative 1. So this is actually x squared minus 4 times negative 1. That's x squared plus 4. Now that's just these two factors here. I needed to multiply that whole thing as well by x. So we're going to have x times x squared plus 4. That would be x cubed plus 4x. So that's a polynomial that satisfies the conditions in part C. You could just give me the formula. If you want to give it a name, I'm going to call this one f of x. You're free to call it whatever you want, but you need to give me the formula in descending order. Now again, if I wanted to, I could multiply this by any integer, by any integer. That would not change the degree, and it would not change the zeros. But I can't have any more factors that have an x in them. And sometimes people think, in a problem like this where we had two factors, and so if we just worked with those two factors, we were going to get something of degree 2. Sometimes people try and say, well, let's just multiply by an x. That'll raise the degree. But anytime you multiply by x, you're introducing that 0 is a 0. And so if you were told these are the only zeros, there's going to be no factor of x. We had to do what we did instead, which was make one of the corresponding factors for the zeros that we did have simply be repeated so that that 0 had a multiplicity of 2. All right,